So we've given you a good introduction to the architecture of the dsNet. You understand that our primary value in the market is giving organizations that need to store very large amounts of data a better way to do it, a way that's highly reliable, highly available, very secure, and more cost effective than what they're typically doing. But having developed a solution to that problem, we ask ourselves the question, what else can we do that will be of value to these organizations? And it's kind of obvious that anything we can do that helps them extract additional value from that data would be good. So we ask ourselves the question, what about if we added a computation capability, specifically the ability to run Hadoop MapReduce using our storage nodes as Hadoop cluster nodes. So you've got this 5 petabyte, 10 petabyte data archive all stored on our dsNet system for a variety of purposes. But what if you could also now launch MapReduce jobs against that data to extract additional value? And based on that insight, we've created a new product which is called dsNet Analytics. And dsNet Analytics focuses on making Hadoop better in a couple of specific ways that are well aligned, again, with the types of customers that we serve, those that are dealing with very large data sets. So, one to highlight primarily is stock standard Hadoop stores data in a file system called the Hadoop Distributed File System. And the Hadoop Distributed File System makes 3 copies of everything that you store there so that it can keep it reliably present in the cluster. So what we're doing is replacing that storage architecture with our dispersed storage architecture, which means the data is stored more reliably, but with less overhead. You don't have 3 copies of the data. You have 1 expanded copy of the data, so you need much less disk storage to store this data on which you're going to run Hadoop. So if you're talking about a petabyte or 5 petabytes or 10 petabytes, that's a very significant cost savings. There are also some notable single points of failure in the standard Hadoop architecture. I'll highlight the name node where all the metadata is stored on a master server. So if for any reason you would lose your master server in your Hadoop cluster, you wouldn't be able to access the metadata, you wouldn't be able to access the data, you'd be kind of dead in the water. Because our architecture already allows you to store all the metadata associated with your objects or files in a dispersed way across the storage nodes, we're also able to eliminate that single point of failure. So we basically take stock standard Hadoop, we change nothing about the compute level. So from the point of view of how you create jobs, what jobs look like, whether you can run the exact same job on dsNet Analytics and any other Hadoop cluster, yes you can. Everything's exactly identical on dsNet Analytics to any other Hadoop environment that you would find out there in the market or in the world. Where we've changed things is inserted our dispersed storage architecture underneath the HDFS interface. So everything that talks to HDFS talks to us without being modified in any way, but behind the scenes you get the benefits of reliability from erasure coding rather than making copies and paying for copies of storage, and you get dispersed metadata, which eliminates a single point of failure in your Hadoop environment. So if you take the picture that Russ showed you before of just regular dsNet and add the things that dsNet Analytics brings to the party, you end up with a picture like this, where now, in addition to the multiple storage protocols that we support for all storage users, we also have an HDFS interface. So for any purpose you want to read and write data to store in a dsNet using the HDFS interface, you can. You would use whatever Hadoop tools you use for any other Hadoop cluster to create jobs and submit them to the dsNet, and then they're going to run on all your storage nodes, which are going to make up your Hadoop cluster. So with that introduction, what I'd really like to do is show you a little bit about what this looks like running on a live system. So the first thing I'm going to show you is here we just have 2 different views into the data stored on this particular dsNet. So in the terminal window, I'm talking to a separate client that's using the HDFS file system interface to list what's stored in a particular vault on my dsNet. And then this window is showing a view of the exact same vault on my dsNet as it appears using a WebDrive client. So I've got a WebDrive client on my laptop that basically gives me, from a UI point of view, what looks like a Windows file system view into the same vault. And you can see it's showing me the same structure, the same data. I can scroll around through the data in a very user-friendly way here. If I want to add some more data, I'm gonna take this adorable picture of my grandson and store it in the dsNet just by dragging it into the WebDrive interface. And then if I update the HDFS view of that same file system, you're going to see that that file is now going to appear in the listing. So the idea here is you're not limited to only HDFS as the way to read and write data into the storage that you're using to support your dsNet analytics. So there you can see that the picture has appeared here in river.jpg that I used WebDrive to actually store into my dsNet vault. Now I can look at this dsNet using the same manager interface that Ramin demonstrated quite extensively. You'd see only one real difference in this dsNet, other than it's a different number of storage nodes and things like that from the other one, and that's if you go to this configure window and you look at the storage pools and the configuration of the particular storage pool, you'll see this item here that says dsNet Analytics. So literally, this is the same build of our software, ClevOS, on those storage nodes, and you have the ability to turn on or turn off the capability to run MapReduce jobs on your set of storage nodes, in addition to the ability to use them to store data in the standard way. And in terms of monitoring what's happening with your Hadoop jobs as they run, this is just the standard web UI that's provided as part of Apache Hadoop, and it allows you to see the status of different jobs that are running, what state they're in. You can also look at the nodes that are in the cluster. So this will show you a view. This is really my dsNet that I'm using for this demo, only has 4 slice stores, 4 storage nodes, and this is what they look for or look like from the Hadoop web interface perspective. So, again, to kind of wrap things up, what you get with dsNet Analytics is an extension to the value that you receive from the dsNet. Now, are you not only able to store a lot of data very reliably and very cost effectively, but you can extract value from it using MapReduce. And we've improved on standard Hadoop from a storage point of view by replacing triple replication with information dispersal or erasure coding, so you get more cost-effective storage, especially at large scale. We eliminate that single point of failure, and we allow you to use all the other standard Hadoop tools, jobs, components, and interfaces that you would use with any other cluster. So with that, can I take some questions?
I might have missed. Did you commit the changes back upstream to Hadoop so they can use erasure coding too?
We have not committed our erasure coding upstream to Hadoop. No, for us, this is a Cleversafe proprietary extension to standard Hadoop.
Apache license, so that's cool.
There are other things that we're working on as part of general Hadoop. We're finding opportunities to improve Hadoop in general as we work with it on this project. And those, of course, we will submit back through Apache to be incorporated. They're in areas other than our dispersed storage implementation.
I think you can think of it as a clean API, the HDFS API that separates dispersal from traditional.
Okay.
And the dispersal piece is obviously the piece that is proprietary to Cleversafe. Above that, anything that would change would be contributed back.
Cool. Thank you.
All right. Any other questions?
No.
All right. Well, thank you very much.
So that's it. That's the Cleversafe story.
Okay, I have another question.
For any of us.
Sorry. And what about OpenStack? Because if you have implemented this thing about Hadoop, you potentially implement a cluster of OpenStack nodes in the same way, more or less.
So yes.
It's a different workload, I can imagine.
It's a good insight. We'll do very similar things with OpenStack that we did with Hadoop, and that is above that clean API. We will look to the OpenStack world, all the various pieces of OpenStack, just like we're OpenStack storage. But below that, we'll use dispersal, we'll use accessors and slice storage, our own proprietary technology. Again, OpenStack out of the box is a replicated object storage system. The Swift piece is replicated object storage, which we don't think is very efficient because you're making multiple copies of individual objects. We think it's more efficient to slice and disperse data and make it more reliable by doing that, and more efficient because you're storing one instance of the data plus a little bit of overhead, the expansion that Ramin talked about, to deliver levels of reliability that are equivalent to 6, 7, 8 copies of the data. So we'll do the very same thing with OpenStack. We actually have that working in labs today, where the interface looks just like it does to your application, like you're talking to an OpenStack Swift environment, but below that it will be Cleversafe dispersed storage. Did that answer your question?
Yes, thank you.
There's other well-known protocols out there. We mentioned one, I think Ramin mentioned one, that calls their containers buckets. They just announced, I think, a day or two ago that they reached 2 trillion objects in their storage system. We've already implemented a majority of their API to talk to a dispersed storage system. So any application that can talk to that storage system can talk to Cleversafe without changing, because we've done the work to implement their API calls in how we manage the data.
That WebDrive.
WebDrive, same thing. Other questions for any of us?
No.
Hopefully this was helpful. I mean, we wanted to show you, live running things and actual working things, and other than not coordinating on firewalls in the original part, which actually ended up working just fine. Hopefully you got a feel for the robustness and the capabilities of Cleversafe, and then some of the add-on components that we made available to our users and our customers, because they really want to take advantage of the reliability, availability, and security from a storage perspective with these various applications.
Well, going back to like the virtual appliances and things like that, so if you're using if you're not using your hardware, obviously you can only go as fast as your hardware will allow you, but since it's not optimized for Cleversafe, are you going to notice a big performance dip there?
Actually, we have not. We've done a number of studies with a number of different companies, and as long as, we use VMware, obviously, from a hypervisor perspective, as long as VMware can manage the hardware efficiently and can deliver level of performance that is required for this type of operation. Again, different tiers of the architecture require different amount of either performance, either on the compute side or storing and retrieving the data side. So as long as we can tune the VMware environment to meet the requirements of CPU capacity, memory, etc., that we need, our application can run very efficiently in a VM environment, and you'd see no degradation. Now, where you will see a difference is we're not controlling every individual disk drive. So like what Ramin showed, that whole list of disks and what's failing, that's now being controlled by the hypervisor, right? You still set up vaults and you still set up, users and that kind of thing through us, but sorry, I'm being asked to mic up. So we wouldn't control all the hardware in that environment, but you can still get the advantages of reliability and availability and security that we provide, because the software there just runs on top of traditional or other type of hardware.
Sure, okay.